So here we are going through SQL joins like inner join, left join, right join, full join, cross, self, semi, anti join. Okay. Before going to join, let we check the structure of these tables. So if we run this SQL query, we are getting two rows, category ID, category name, which are having around 10 rows. Okay. And if we run this SQL query, yeah, one more thing, you can see last three rows which are having some new records, category ID 11, 12, and 13 with name category 1, category 2, category 3. Basically these categories are not a part of category product table, and we have added newly to play with this join operations. Okay. Now if we run product table, we can see that there are 326 records in product table, where we are having product, product name, company ID, and category ID. This category ID is referring to this category table, then manufacturing one, and product price. Now again, to play with the join operations, I have added some records in this product table as well, and those records are this one. So for this product, these products, we have used category ID 15. This category ID 15 is not available in this category table. Okay. So there are 5 records in product table which are having category ID 15, which is not matching with the category ID from category table. Now, if we run this inner query, so what this inner query is doing, it is getting applied on this product and category table with condition on category ID of product table should get matched with the category ID of category table. Okay, and if we run this one, we are getting 321 rows. Total how many rows was there? 326. Similarly here, so when we executed this inner join, there are around 321 records where category ID is matching, and if we see here, as I told earlier, 5 rows are there which are newly added and not having category ID matching with the category ID of this category table. Now left join, we are applying this left join on product table and category table, and with the condition, again similar condition, product dot category ID should be equal to category table dot category ID. Again, since it's a left join, so we will get 326 rows, but there are around 321 rows are matching. For remaining 5 rows, what will happen? Let's check. See, we are getting 326 rows, but you can see the columns: product ID, product name, company ID, category ID, manufacturing one, product price. This all the rows from product table, and last 2 rows category ID and category name. These are from category table. Okay. So if we go down, we can see that for those 5 rows, the values was not matching. We are getting null values to category ID and category name. Okay. Similarly, if we use right outer join, in case we execute this right query, so we are getting all the rows from category table. That is all 10 rows. Out of these 10 rows, 7 rows are matching with these products, whereas there are 3 rows which are not matching with this category ID of product table. You can see we are getting 324 records, and out of these 324 records, these are the 3 rows from category table which are having category ID 11, 12, 13. These category IDs are not available in product table, and that's the reason all the product columns are getting null value. Okay. Now what will happen in case of full outer join? So if we run this one, we are getting around 329 records. But the interesting thing is, if we go down, we can see that we are getting all the records. Okay, all the matching records as well as not matching records from both the tables. Here for product 1, 2, 3, 4, 5, we have provided category ID 15. This category ID 15 is not available in category table, and that's the reason we are getting null value to these rows. Whereas for category ID 12, 13 and 11, we don't have product, and that's the reason we are getting null values to product columns. Okay. Now let's go to cross join. As we discussed earlier, cross join is a Cartesian product. So if we run this one, we can see we are getting around 3260 records. Okay. So it is again matching to all rows. So if you see here, all these products are matching with category ID 1. Once all these records completed, then category ID 2 will get start. And 326 records are there. All these 326 records are matching with category ID 1. Then next 326 record will match with category ID 2, and so on. Now self join. Before executing this self join, let's understand what is there inside this employee table. So we can see that we are having employee ID, first name, last name, email, phone, active, shop ID, and manager ID. Forget about all these other columns. Okay, just focus on employee ID, whose first name and whose manager ID. Now if somebody asks you that in this particular row we also want manager's information, like whose first name. Okay, so in that situation we can use this self join concept. If we run this one, you will see for this employee ID 2, that is Milind, we will get manager ID 1 and whose all the details. Then for employee ID 3, we will get manager ID 2, and this manager ID 2 will get all his detail. Okay, so basically self join is used on this type of hierarchical data. Now move to semi join or left semi join. So in case of semi join, we are getting all the records which are available in product table as well as in category table. Okay, but we will get all the columns from product table. If we run this one, we are getting around 321 rows which are having product ID in product table as well as in category table. Okay, we can write this type of query using in operator as well, and here we are just looking for similar result. So if we run this one, we are getting 321 records. Okay, then anti-join or left anti-join. So again here we are getting the records from left table, but which records? The records whose category ID is not available in another table, that is category table. So if we run this one, we will get 5 records. All these 5 products which are having category ID 15, this category ID is not available in category table. Okay, sometimes people are using this query and we are getting same results. Here if we use star, we are getting all the records, but you can see that we are getting category ID and category name with null values. But in case of left anti-join, we should get the columns from left table. So either we can do one thing, rather than providing star, we can provide the name of each column, like product ID, product name, company ID, category ID, manufactured on, product price from product table itself. Or else we will just provide product ID and then we will write outer query with star from product table and then use it. Okay, so that's it for this particular video.
So enjoying this
Thank
video?
you.
Subscribe to our channel for more exciting content like this. Don't forget to hit the bell icon to get notified whenever we post a new video. Thanks for watching.